we propose a novel, continuous collision detection method for convex collision shapes with piecewise affine trajectories. We design our algorithm based on two key properties of stiff body simulation. First, both of the collision shapes are convex. Second, the motion of each collision shape has a constant affine velocity, which means that their body-to-world transformation matrices changes linearly over time. Under these assumptions, we can compute the time of impact iteratively using conservative advancement. In each iteration, we compute a lower bound estimate of the time of impact by casting a cone onto the Minkowski difference of the two rest shapes. The cone is defined by the affine velocities of the collision shapes. The collision time between the cone and the difference is always earlier or equal to the actual time of impact. This cone casting method is a generalization to the ray casting method, a classic continuous collision detection algorithm that only handles translational motion. Our method integrates seamlessly into affine body dynamics, the state-of-the-art, non-intersection stiff body simulator. For non-convex collision shapes, we first decompose them into convex proxies using approximate convex decomposition. In single-threaded experiments, our method achieves a tenfold speedup over the primitive-based ACCD algorithm. Parallel simulation of multiple scene instances further improves the throughput by 14 times on a multi-core CPU. This is particularly beneficial for applications like robot training, which often require batches of simulated samples. Thanks for your attention.